This is problem number 35 from the June 2015 Algebra Regents exam. An online electronics store must sell at least $2,500 worth of printers and computers each day. Each printer costs $50 and each computer costs $500. And the store can ship a maximum of 15 items per day. And what we need to do is in this, we need to graph a system of inequalities that models these constraints. So we're going to take this information and turn it into a couple inequalities. Now I notice the word at least is helpful. That's an inequality, right? So the amount of money they're making needs to be at least $2,500. Now let's figure out how to express that inequality. So each printer is $50. So if we did 50 times P for printers, that would be the amount of money they're making. Or yeah, how much money they're making on printers. And then each computer is $500. So we would do 500 times C for the number of computers that they sell. So 50P plus 500C would represent the amount of money they're making on printers and computers, and we want them to make at least $2,500. So that's our first inequality. Now, because we can see that the number of computers is our dependent variable, or the y value, the y-axis, it would be helpful to isolate C in this inequality. So we're going to move the 50P over to the other side. So let's say negative 50P plus 2,500. And then we could divide everything by 500, and we get C is greater than or equal to negative 1 over 10P plus 5. Okay. That's going to help us later on. Now, for the second inequality, is the amount of items they can ship per day. It's a maximum of 15. So if we were to add the number of printers they sell plus the number of computers they sell, because the maximum is 15, it can't be more than 15. But it could equal 15. So the inequality we're going to use is that they has to be less than or equal to 15. And again, it's going to be helpful to isolate our C here. So I'm going to do C is less than or equal to negative P plus 15. Now it's a handy to use your graphing calculator in this part of the problem, and what you would do is write these in as equations, negative 1/10 x plus 5, and the other one over here, negative x plus 15. So if you type those into your graphing calculator, that'll make the process faster for graphing this. I'm going to zoom in here, make this a little bit easier. Now for that first equation, some key ordered pairs would be at 0, 5, 10 and 4, and 20 and 3. And of course on your graphing calculator you might need to play around with the window settings a bit to make this quite more visible. Okay, so let's connect these together. All right. So let's label that one. That was C is greater than or equal to negative 1/10 P plus 5, I think. Is that right? Yes. Okay. Now for the next one, we'll check C is less than or equal to negative P plus 15. And it should look something like this from here to here. And I'll just quickly connect those together. There, that looks about good. Now since for this inequality, we want C to be less than or equal to this line, so we're going to highlight this section here. And then for this one, we want C to be greater than or equal to this line. And so then we're going to highlight this section like this. So we'll see where they intersect is this area here. Let me use my highlighter. So this is the area that we're interested in. Now, for the final part of this question, we're being asked to determine a combination of printers and computers that would allow the store to meet all of these constraints, and explain how you obtained your answer. And that's fairly straightforward. All we need to do is choose a point that exists in this range here that we've been talking about. So literally any point would work as long as it's in here. For example, we could do 3 and 7. And that means there'd be 3 printers sold and 7 computers. So you could simply say that 3 printers and 7 computers would allow the electronics store to meet the constraints, and the explanation would be that the coordinates 3, 7 are within the constraints of these system of inequalities. Okay, hope that was helpful. Thanks for visiting JD's Regents Preparation.